History of mechanical engineer. The application of mechanical engineering can be seen in the archives of various ancient and medieval societies. The 6 classic simple machines were known in the ancient Near East. The wedge and the inclined plane, ramp, were known since prehistoric times. The wheel, along with the wheel and axle mechanism, was invented in Mesopotamia, modern Iraq, during the 5th millennium BC. The lever mechanism first appeared around 5,000 years ago in the Near East, where it was used in a simple balance scale and to move large objects in ancient Egyptian technology. The lever was also used in the shadoof water lifting device, the first crane machine, which appeared in Mesopotamia circa 3000 BC. The earliest evidence of pulleys date back to Mesopotamia in the early 2nd millennium BC. The sakya was developed in the kingdom of Kush during the 4th century BC. It relied on animal power, reducing the toll on the requirement of human energy. Reservoirs in the form of hafers were developed in Kush to store water and boost irrigation. Bloomeries and blast furnaces were developed during the 7th century BC in Meroe. Kushite sundials applied mathematics in the form of advanced trigonometry. The earliest practical water-powered machines, the water wheel and watermill, first appeared in the Persian Empire, in what are now Iraq and Iran, by the early 4th century BC. In ancient Greece, the works of Archimedes influenced mechanics in the Western tradition. In Roman Egypt, Heron of Alexandria created the first steam-powered device. In China, Zhang Heng improved a water clock and invented a seismometer, and Ma Jun invented a chariot with differential gears. The medieval Chinese horologist and engineer Su Song incorporated an escapement mechanism into his astronomical clock tower, 2 centuries before escapement devices were found in medieval European clocks. He also invented the world's first known endless power transmitting chain drive. During the Islamic Golden Age, 7th to 15th century, Muslim inventors made remarkable contributions in the field of mechanical technology. Al-Jazari, who was one of them, wrote his famous Book of Ingenious Devices in 1206 and presented many mechanical designs. Al-Jazari is also the first known person to create devices such as the crankshaft and camshaft, which now form the basics of many mechanisms. During the 17th century, important breakthroughs in the foundations of mechanical engineering occurred in England. Sir Isaac Newton formulated Newton's laws of motion and developed calculus, the mathematical basis of physics. Newton was reluctant to publish his works for years, but he was finally persuaded to do so by his colleagues, such as Sir Edmund Halley, much to the benefit of all mankind. Gottfried Wilhelm Leibniz is also a mechanical engineer. Mechanical engineering is an engineering branch that combines engineering physics and mathematics principles with materials science to design, analyze, manufacture, and maintain mechanical systems. It is one of the oldest and broadest of the engineering branches. The mechanical engineering field requires an understanding of core areas including mechanics, dynamics, thermodynamics, materials science, structural analysis, and electricity. In addition to these core principles, mechanical engineers use tools such as computer-aided design, CAD, computer-aided manufacturing, CAM, and product lifecycle management to design and analyze manufacturing plants, industrial equipment and machinery, heating and cooling systems, transport systems, aircraft, watercraft, robotics, medical devices, weapons, and others. It is the branch of engineering that involves the design, production, and operation of machinery. Mechanical engineering emerged as a field during the Industrial Revolution in Europe in the 18th century, however, its development can be traced back several thousand years around the world. In the 19th century, developments in physics led to the development of mechanical engineering science. The field has continually evolved to incorporate advancements. Today, mechanical engineers are pursuing developments in such areas as composites, mechatronics, and nanotechnology. It also overlaps with aerospace engineering, metallurgical engineering, civil engineering, electrical engineering, manufacturing engineering, chemical engineering, industrial engineering, and other engineering disciplines to varying amounts. Mechanical engineers may also work in the field of biomedical engineering, specifically with biomechanics, transport phenomena, biomechatronics, bionanotechnology, and modeling of biological systems. Job duties. Mechanical engineers research, design, develop, build, and test mechanical and thermal devices, including tools, engines, and machines. Mechanical engineers typically do the following. Analyze problems to see how mechanical and thermal devices might help solve the problem. Design or redesign mechanical and thermal devices using analysis and computer-aided design. Develop and test prototypes of devices they design. Analyze the test results and change the design as needed. Oversee the manufacturing process for the device. Mechanical engineers design and oversee the manufacturing of many products ranging from medical devices to new batteries. They also design power-producing machines such as electric generators, internal combustion engines, and steam and gas turbines, as well as power-using machines, such as refrigeration and air conditioning systems. Like other engineers, mechanical engineers use computers to help create and analyze designs, run simulations, and test how a machine is likely to work. And test how a machine is likely to work. And test how a machine is likely to work. And test how. If you like my video, please like, share and subscribe. Thank you for watching my video.